Hello, my name is Gustavo Rovelo Ruiz, and on behalf of my colleagues Hitesh, Dhiman, Leen, Ramakers, and Carsten, Röcker, I will present our work designing instructions using self-determination theory to improve motivation and engagement for learning craft. Several industrialized countries in Europe and in the world are faced with an aging workforce, resulting in an increasing number of experts from different domains set to retire in the coming years. This is especially problematic for crafting skills that are traditionally learned through apprenticeship. Examples of such crafting skills include woodworking, welding, brazing, and butchery. And to learn such craft, it is necessary that novices follow instructions and receive the guidance from an experienced person who can share the art of the craft. Such process requires constant practice and perseverance, as in many cases, failing is a necessary part of the process. In this case, it is important that novices remain motivated while learning. Thus, we need alternatives that can help, on the one hand, preserving the implicit knowledge and craftsmanship from experts, and on the other hand, that can help us training the new generation of experts in a more efficient way. The self-determination theory is a theory of human behavior that offers a framework to investigate facilitating factors that can positively influence people's engagements, persistence, and motivation in everyday activities. While the self-determination theory divides human motivations into categories, intrinsic and extrinsic motivation, research shows that intrinsic motivation often results in higher persistence, performance, and satisfaction. In addition to these two basic forms of motivation, the self-determination theory proposes three psychological needs, including competence, to feel effective, autonomy, self-endorsement and ownership of actions, and relatedness, to feel connected and involved with others. Intrinsically motivating contexts are associated with the fulfillment of these needs with positive effects on subjective and objective outcomes for the tasks at hand. Prior research has largely focused on supporting self-determination theory in educative systems in the context of formal education and the transfer of abstract knowledge and skills such as learning languages, chemistry, mathematics, or writing essays. In educational settings, the self-determination theory provides an extensive collection of teacher behaviors that can effectively support psychological needs in in-person settings. These can broadly be categorized into three groups: improving participants' understanding of what and why an activity has to be performed, and optimizing how these two aspects are communicated. In our research, we investigated how we can use the self-determination theory heuristics to design step-by-step instructions for learning crafting tasks. As we mentioned before, intrinsically motivating trainees is especially important in crafting tasks, as it requires persevering through important detailed instructions that have implications in later steps. Thus, in our second contribution, we empirically evaluated the impact of these self-determination facilitating factors on task performance, as well as cognitive and affective states such as competence, intrinsic motivation, meaning, and stress. Finally, we offer guidelines on how researchers and practitioners can leverage our results in the design of digital instructions for crafting tasks. To do this, we designed a between subjects study with 30 participants, so three groups of 10 participants each, to answer these two questions. Do self-determination theory suggestions also work in designing digital instructions for crafting tasks? And do we also see changes in instruction use and workmanship quality? In this case, we chose for a woodworking task where participants had to build the wooden stand that you can see here at the bottom right of this slide. To do this, we divided this activity in 5 tasks, 27 steps in total, where participants receive different instructions to perform the steps to complete the tabletop. And in some cases, they also had some opportunities to decide whether or not follow one step. For example, setting the different depths of the wood router to carve the wood to create the finger joints. In our study, we used a projected augmented reality interface where the participants could explore the different instructions screens and play back the videos with a first-person view of an expert performing the activity that they would have to replicate to perform each one of the tasks. We had 3 different levels of instructions. The first one was basic textual instructions that you can see here in gray color on both screens, the one on the left showing the introduction of the tasks and the one on the right showing how the content was displayed for the instructions of each one of the steps. In this case, and for each one of the steps, we showed videos embedded with annotations to highlight the details of each one of these steps. In the level 1 of our study, we added goal clarity text, and also we included before and after pictures per step. Finally, level 2, we added acknowledgement and rationale of each one of these steps, trying to empathize with any possible negative feeling that the participants would have due to frustration while performing the tasks. And the multimedia stayed the same. The results of our study, for example, in terms of perceived competence, showed a significant difference between the 3 conditions. The Tukey post hoc test reveals a significant difference between conditions L0 and L2. The figure on the left, you can see this linear increased in the competence feeling when the number of facilitating factor increases. Another of our hypotheses stated that participants' intrinsic motivation to practice the activity in the future would also increase with the level of instruction. The results shows that there is no significant difference, but as you can see on the figure on the right, there is a positive trend with respect to the level of instruction. So level 0 reporting the lowest levels, followed by L1 and L2 reporting the maximum intrinsic motivation. In terms of the use of instructional content, that is watching the videos, we hypothesized that this would lower as the level of instruction increased. To analyze this, first we checked how many times on average participant would play the videos on the different conditions. And in this case, the result of the Kruskal-Wallis test is significant, as you can see on the figure on the left, where participants in L1 and L2 engage with the videos significantly less amount of times compared to the control group in L0. Next, we analyzed how many times participants in different conditions visited the instructions, that is, change between the screens with instructions for each one of the steps. The differences in this case are also statistically significant, where L0 had the highest count, followed by L1 and L2. To conclude, introducing goal clarity by, for example, complementing the video with before and after photos for every step increases perceived competence, intrinsic motivation, and task quality. At the same time, it reduces the number of times participants are required to consult the instructions. Second, our results show that introducing rationale and acknowledgement in the digital instructions leads to further improvements in the quality of the results, showing that if users understand the rationale for a decision, they are more confident about the options they picked. And in this case, this additional information and time resulted in improved quality of the product, higher competence, and intrinsic motivation. Third, one would expect that introducing goal clarity, rationale, and acknowledgements in the instructions increases the mental load, as they increase the amount of textual and visual information that has to be processed. However, in our results, mental load did not significantly differ across the different conditions. One reason for this could be that different kinds of mental effort were required for the different conditions. Finally, while prior research shows that when a task is uninteresting or the goal is unclear, providing rationale can make it more meaningful. In our study, introducing rationale did not significantly affect the perceived sense of meaning. As we argue in our paper, when the task itself has a clear end result and the user can grasp and reason about it, rationale may not always add additional meaning for participants. Thank you for your attention.